Hello students, welcome back to my channel. This is Harsh and today we will discuss miscellaneous exercise intro. So let's begin without wasting time. Our first and the 18th example is, let R be the set of real numbers. Define the relation function, the real function on real to real numbers by fx equals to x plus 10 and sketch the graph of this function. Let R be the set of real numbers. The set of real numbers, we need to define the real function on R to R by fx equals to x plus 10. Okay, and afterwards we need to sketch the graph of this function. Sketch graph. Okay, in this question what the examiner is basically asking, he is asking that let R be the set of real numbers and the function is defined on real numbers by fx is equal to x plus 10, and we know we need to sketch the graph of this function. Okay, let's have a look at the solution. Consider a few points like function defined on 0 equals to 10 because 0 plus 10 gives us 10, and when we take function on 1 we have 11, function on 2 we have 12, and simultaneously and continuously it goes on. Okay, and let's take a last point, which is f of minus 10. What will f of minus 10 give us? Minus 10 will give us 0 goes minus 10 plus 10 gives us 0. Okay, let's draw the graph of this function. Okay, 1 2 3 1 2, let's take this in the gap of 5 10 15, 5 10 15, minus 5 minus 10 minus 15, minus 5 minus 10 and minus 15. So what was our first point? When we considered 0, the maximum value was 10. Okay, this was the value when we took 0, x equal to 0, y was what value, y was 10. Okay, and when we have considered minus 10, the value is 0. Let's say this point. Okay, and we need to draw a graph, and the graph will be like this, a straight line. And thinks this is not a straight line, but I'm not having a scale, and that's why I'm using rough diagram. Okay, so let's have a look at the 19th example, but before that pause the video to note it down. Okay students, let's have a look at the 19th example, which states that let R be the relation from Q to Q defined by R is equal to AB such that AB belongs to the Q and A minus B belongs to the integer. Okay, let me write down the statement. R is a relation from Q to Q defined by Q to Q defined by R equals to AB such that AB belongs to Q. And what is this Q? I am repeating this Q again and again. This q refers to the set of rational numbers, okay? And a minus b belongs to integer. A minus b belongs to integer. Okay, let's have a look at the solution. No, but before that, we are having three parts. Our first part is a belongs to real number for all a belongs to q. Okay, let's read the statement once again. Let R be a relation from q to q defined by R equals to ab, and ab belongs to the q and a minus b is integer. Show that a belongs to real number for all a belongs to the rational numbers. Okay, let's have a look at the solution of this first part. Our solution is, since we know that a minus a always gives us 0, and 0 all belongs to the integer, and from this we can say that a belongs to the integers. Okay, we are given here that a minus b belongs to integer. We need to show this. Let's say a minus a equals to 0 and 0 belongs to integers, set of integers, and we can say that it follows a belongs to real number. What we need to prove? We need to show that a belongs to the real numbers. Okay, we have taken this function a minus b belongs to integer. We have taken two real number a, we have taken two numbers a, and after subtracting them, a minus a, we got 0, and 0 we can say that it belongs to integers. Thus we can also say that a belongs to real numbers. Okay, this was the solution of the first part of the 19th question. Let's have a look at the second part. Okay, but before that, pause the video to note it down. Okay students, let's have a look at the second part of this question. It states that ab belongs to R implies that BA belongs to R. BA belongs to R. We need to show that AB belongs to R implies that BA also belongs to R. Let's have a look at the solution. Since we know that AB belongs to R implies that A minus B implies that A minus B belongs to integer, so B minus A also belongs to integer. Therefore BA belongs to real number. BA belongs to real number. This type of question are not very difficult. What they ask for, just the presence of your mind. If you have your presence of mind, you can do this question simply. Otherwise, if you don't have, it will take a long time to solve these questions. But these questions are nothing. Okay, what I did here, AB, it was given that AB belongs to the real number. AB belongs to real number implies that A minus B belongs to integer. A and B are the two numbers, imaginary numbers. Let's say you have considered one for A for 1 and B for 2. Okay, and if we subtract A minus B, which is 1 minus 2, we got minus 1, and which belongs to the integers, and therefore we can also say that B minus A will also give integer. Okay, let's say A equals to 1, B equals to 2. Okay, when we subtract A minus B, we have 1 minus 2 equals to minus 1, and minus 1 belongs to integers, And after that we can also say that 2 minus 1 also belongs to 1, also belongs to integers, and therefore ba belongs to real number. This thing you need not to show the examiner. What you need to show is this thing. Okay, let's have a look at the third part, but before that pause the video to note it down. Okay students, let's have a look at the third part of this question. It states that AB belongs to R. We need to show that AB belongs to R and BC belongs to R, and BC belongs to R implies that AC belongs to R, implies AC belongs to R. Let's have a look at the solution. Okay, since you know that A, B and BC belongs to real numbers, it is given here AB belongs to R and BC belongs to R, it is given here, and implies that it implies A minus B belongs to integer, and so B minus A also belongs to integer. The same concept is applied here which was applied in the second part. Okay, B minus A, therefore we can say that so A minus C equals to A minus B plus B minus C belongs to integer. Okay, what we did here, we simply added these two numbers. Okay, A minus B and B minus C. Okay, what we have here, A minus C belongs to integer. Simple. There is nothing long in this question. This is a quite tricky question, and this type of question doesn't comes in your exams. Okay, students, pause the video, note it down. Okay students, let's have a look at the example 20. Okay, let f equals to 1 1 2 3 0 minus 1 0 minus 1 minus 1 minus 3 minus 1 minus 3 be a linear function from z into z, be a linear function from z to z. Find fx. We need to find out the function. Okay, let's read out the statement once again. Let f equals to 1 1 2 3 0 1 0 minus 1 minus 1 minus 3 be a linear function from z to z. We need to find out fx. Let's have a look at the solution. Okay, since f is a linear function, we can say that fx is equal to mx plus c. Okay students, there is an important point. Okay, this, if there is a linear function, you can simply write fx equals to mx plus c. Mx plus c, you can simply write this, where x belongs to the real numbers. This type of function is called linear function, where m and c are constant, and m and c are here constant. I am writing here m and c are constant, k for constant. Okay, and this type of function is called linear function. I am marking this dash. I am gonna erase this, and before that you can write it down in your notebooks. Okay, since f is a linear function, we can write it down. Fx equals to mx plus c, mx plus c, Also, since 110 minus 1 belongs to real number, we can say that f of 1 equals to m plus c equals to 1. Okay, what does this mean? I have considered it was given that 1 1 and 0 minus 1 belongs to real numbers, and I have just put in the value here. Okay, and f0 equals to c, which gives us minus 1. How? Wait, let me write the solution, then I will tell you. This gives m equals to 2 and fx equals to 2x minus 1. Since I told you, since 1 1 and 0 minus 1 belongs to R, minus 1 belongs to R, I have just taken these f1 equals to these things. Okay, I have just put it 1 in the place of x, and which gives me 1. Okay, one a coordinate here with on the place of x, and this was taken here. Okay, when I took 0 on the place of x, it that give me 0, and the remaining term equals to c minus 1. Okay, now comparing these equations, we get m equals to 2. Okay, and the function which gives us is 2x minus 1. Okay, students, this is a tricky question and most important question as well, so I'm marking this hash. Okay, memorize this question or get this question learned, not learned. Okay, now let's move to the 21st example, but before that, pause the video to note it down. Okay students, let's have a look at the 21st example, which states that find a domain of the function which is given by fx equals to x square plus 3x plus 5 by x square minus 5x plus 4. Okay, we need to find a domain of this function. Okay, and right here domain. Let's have a look at the solution. Since this type of question comes in your competitive exams like IIT, JEE and NDA, and let's have a look at the solution. The simple trick of this question to solve is simply take this question equal to 0 and find the solution of the denominator here. Okay, wait here, let me show you. Fx equals to x square plus 3x plus 5 by x square minus 5x plus 4 equals to 0. Let this be equals to 0. Okay, and find out the solution of this equation by factorization method or any other method. And when we find out the solution of this, we have x square minus 5x plus 4. Its solution will be x minus 4 and x minus 1, x minus 4, x minus 1, and simply we can say that x equals to 4 or 1, and we need to solve this question in such a way that the denominator never gives us 0. Okay, and now we come at the domain. We need to find out the domain, and we need to subtract this for two numbers 4 and 1, so that this function never becomes indefinite or not defined. Okay, so what was the meaning of this question? The meaning of this question was simple. We need to find out the domain of this function which is given to us, and the function is x square plus 3x plus 5, x square minus 5x plus 4. We need to look after this denominator of this question, okay, and simply find out the solution of this equation, whatever it is given here in the denominator. Find out the solutions and subtract it from the real numbers. There is nothing else in this question. This is quite simple question and also important. I'm also marking this hash because this type of questions come in your NDA and competitive exams, okay. Pause the video, note it down. Okay students, let's have a look at the 22nd example, which is the function f is defined by fx equals to 1 minus x when x is less than 0 and 1 when x is equals to 0 and f plus 1 when x is greater than 0. A function is defined by one minus x when x is less than 0 and 1 when x equals to 0 and f plus 1 when x is greater than 0. Okay, draw the graph of this function. We need to draw the graph. Okay, draw the graph. Okay, let's have a look at the solution. Okay, here let's here we have given that 1 minus x is less than 0. Okay, and let's take function f minus 4 which is less than 0. 1 f minus 4 such that 1 minus 4 we have 5 here because minus minus cancel each other, and 1 plus 4 we have 5. When the term come, let's take minus 3. When we take minus 3, 1 minus 3 we have 4 here eventually, and let's say we go till f of minus 1 which gives us 2. 1 minus 2 equal, oh, sorry, it was minus 1, it gives us 2. Okay, and simply we can also say that f of 1 equals to 2, f of 2 equals to 3, f of 2 equals to 3, and so on. The values goes on rising. Okay, from here we conclude that the graph of this function will be like this. Let's say the values are 1 2 3, 1 2 3, minus 1 minus 2 minus 3, 1 2 and 3, minus 1 minus 2 minus 3. Okay, the function is x. When the value of x equals to 0 we have 1 as a solution, and when the value of x is less than 0 the function is like this, starts from infinity and goes like come till 1, and after that the function goes like this because the value, when we use the function 1 minus x we have the negative values which was starting from this. Okay, and when we take this function x plus 1 we have this positive value. Okay, this was the miscellaneous exercise intro. Okay, thank you for watching this video, and if you like the video please hit like button and subscribe my channel. Thank you once again for watching this video.